that this can kill you, and it will hurt the whole time it's killing you, as it says. I feel confident in my abilities to work safely in here. I am doing the one-hand method, which means when you're dealing with electricity, one hand goes in the pocket or to the side, but not touching anything. The last thing you want to do is create a path to the ground through your body. It only takes like 0.01 amps across your heart to kill you. So that's why if you're working on something like this, you keep a hand away. You don't want to have a hand up here and touching in there, because that can create a path for ground through your chest, and you don't want to do that. So any time that I feel that it's unsafe to be in here, or if I got too many wires hanging, I'm going to go pull the batteries. Right now I'm just lazy and I find this fun, but personally I should have pulled the batteries on this. But we'll visit that a little bit later. Just know that this area can kill you. There's more than enough amps in a battery. The only reason the battery doesn't kill you when you touch it is because our skin is insulated later, and it prevents the power from jumping. I think you have to have at least like 40 volts, maybe 48 volts DC before it can get through the skin. So if you're messing with high voltage DC current, that can kill you very fast, because it'll grab hold of you and not let you go. With alternating current, at least you have a little cycle in there that you can let go of it. But the DC current will grab hold of you and will not let you go. That's why I intentionally, for the longest time, was resistant to MPPT, because you have high voltage DC that has no break in it or anything else running to it. So when we get to that side of the solar system, we're going to have to uber safetyize it. Uber, I don't even think that's a word, but we're going to have to make sure it's uber safe. We're going to have to idiot proof it, meaning not only us, anyone else is in there, or any this. Basically, I think what I'll probably end up doing is running a bunch of breakers in line with it before I combined it together to give a little bit of safety gap in there. And then when I do finally combine it all, it'll be combined right before it goes in, and it'll have all kinds of safety cages around it where no one can touch it accidentally. But understand that high voltage DC can be deadly, and it will kill you fast. Or slow. It might kill you slowly, just let you hang on and feel the pain the whole time. Anyhow, that's my disclaimer. Electricity is dangerous, including 12 volts. But, yeah. Look at this. Look at that. I don't like how they did their wiring here. Basically, it came from one cluster and went to another cluster and tied everything together with wiring nuts. It worked for them, I guess, and I guess the whole thing was they'd be in there. They have really good wire in here, though. They got this really nice braided wire, which I'm probably going to recycle the wire because it's good wire. It's actually what you want in your mobile vehicle, because it's braided. It can handle vibrations a lot better versus solid core. If you get 110 solid core, it'll break. You'll be tracing a phantom load or something strange like that. So I'm going to go ahead and take this apart and set it aside, because the configuration I have planned for it, I plan on having a separate breaker box. This is a small breaker box, but something's better than nothing, you know. This thing right here, which is interesting in itself, I haven't got the exact diagram. It was loose. But this is the intake, and there's a little plunger in there that pushes, well, somehow pushes this thing out, and I think it pushes something down. Anyhow, it allows the bypass to come on and allows electricity to flow, I think. I don't know, I haven't tore into it to see exactly how it works. There's actually a solenoid here. Maybe it's to turn on a solenoid or something else to say that there's power here. Don't worry. It might be their version of automatic transfer switch too. But that's the power coming in. Oh, look. This goes to my air pump that I disconnected. And I think I'm going to have to come in here and cut down there to get it all the way apart. I'm trying not to get into the electrical wiring too much until I got it organized out here. So I'm going to start pulling out all these systems that I know I'm going to redo out here, including all the AC wire. Whatever this mess is here, it's coming out. It's tied to this mess here. So the switch panel, I'm debating on if I want to positive switch my wires or ground switch my wires. The advantage of ground switching is I only have to run one wire to the switch, and then I run it through the switch and then run it to a ground. The only problem is if it fails, meaning a ground wire shorts out somewhere after the circuit. If it fails before the circuit, it's just going to blow a fuse. But if it fails after the circuit, it's going to just turn on a light or turn on whatever that switch is designed to work on, which should be easy enough to trace down. But basically, it reduces my load or my wire load going back to the relay. And I'm going to use relays in this one. I'm also thinking I'm going to run a couple grounding plates in here and tie it to the batteries themselves, so it'll give me a good solid ground. It should reduce my corrosion on the aluminum. This gives me a place to hook grounds up to that I don't have to worry about. Kind of run some big old wire, probably, because I can't run solid. I don't know, maybe I can find me a piece of solid copper, run the whole length of the cab. But anyhow, the biggest problem is if a positive wire rubs on that, it's going to blow a fuse or fry that wire. So we'll consider it. What we'll probably end up doing is running electrical, like a positive on one side and a negative on the other side, or we'll have some sort of big insulation, probably a PVC tube that pulls all the control wires up front, depending on where they're at. We could use conduit, but I don't see a point. PVC drain pipe's cheap and it'll do the trick. The biggest thing is we need to probably heat up and balloon and create kind of a grommet around the outside so it doesn't sit there and rub, and gives it a nice radius to go around so the wire doesn't break. And we'll put those points where we can easily access the wire and support the wire. I plan on having a as big as I can get away with tube, so it's easier to fish wire through there should I want to add stuff. But I'm hoping I'll have everything figured out ahead of time. This build, I plan on having a security camera set up in it also, just so I can see what's going on outside my rig, and hopefully have a wireless setup, but we'll visit that later. Also, I want to do some like I said, fireproofing in here. That's another thing, and I want to have area lights. The ambulance already comes with area lights, but I don't like their lights. The technology is way better than what it was when this was built, and I can get away with smaller floodlights than what's on here and have them more power efficient and put out more light. So, and I'm trying to figure out how I want the wiring in the cab for the floodlights on all sides. I'll probably have a special, well, I've seen them do it on some other Fords, but I'm going to put a switch panel in the door itself, and it will control probably the front, the left, the right, and the rear light, floodlight, along with the off-road light up front. And if everything builds out the way I want, I'm going to have an extra light control that I can turn on that will give me light outside the door. Not to say if I get pulled over, but if I'm talking to someone like a camp host or driving into campground late at night, it'll probably have a dual function of red and white, and it'll give light outside so we can see what's going on outside the window. Along with in the cab, I'm toying with the idea of running extra red lights in here to give me better night vision and visibility, so I don't have to ruin my night vision by having light, and that will be increased. The also thing, I gotta look it up and verify, but my friend says red is for sleepy, to let you sleep, but you can still see. Green still lets you see at night, but kind of thing, but it keeps you awake longer. I'm also researching some stuff regarding a changing light pattern throughout the day. Granted, I should have plenty of daylight to do it, but I was toying with the idea of getting a program maybe to change the light from what's a morning light, which is a white light, to an evening light, which is a soft white light kind of thing. But we'll revisit that later on once we get the roof raised done and kind of got an idea of what's going on, where the electrical is going to be. Right now, as I've been tearing it apart, I've been seeing how they got the electrical run. We're going to run it different than they got it in here, I think. Mainly because, well, mainly because I'm going to do a 2-foot roof raise on it, and that'll stretch all the wires, and if I want to reuse the wires, I can't do that. But I think what I'm going to do is 2 inches of a rock wool or sound deadening insulation in here, and I did a test drill on this to figure out what kind of material I have and all that stuff the other day. But there's no insulation other than air in these things. I might fill these up with a boat sealant stuff to give it a little more insulation. I don't know yet. Haven't got that far, but thing is about aluminum, it's a great heat transfer device. It transfers heat quite readily. So I got aluminum skin attached to aluminum bars and then bring it in. So this is one big giant heat sink. So I got to figure out a way to break that. I have a couple ideas in there how I'm going to do it, but we'll revisit that later. And some of the other stuff that I'm going to design in here if I can afford it. Aluminum's not cheap, but yeah, we'll see when we get there. I'm thinking a double roof up front, and I'm thinking about spacing the solar off far enough that I don't have to really worry about it, and we'll see if we can get them to butterfly out and give us a little bit more deck space up top. Anyhow, I will be relocating these, along with probably relocating the brakes higher up and a little bit farther back, because I want to be able to put some storage back there and not worry about obscuring my brake lights. So I'm probably going to build a little bump out for the mini split AC unit back there, along with some protection, a place for maybe a Honda 2000 generator, because those things are dead quiet, very quiet, and they take a little fuel. And probably below that I'll have a spare fuel location, maybe 1 or 2, along with a couple spare diesel tanks, some recovery gear, mainly like mat tracks or whatever they're called. That helps you get out of muddy situations. And maybe a few other things. I might put the spare tire back there and leave it out of the boxes. Also to note, if you guys look down and around, the floor is going to be about 1 foot, and it'll probably be close to 16 inches. So this box won't even be in the living space, but it'll be in the insulation space. So I plan on insulating everything, but I plan on doing a false floor so I can have my batteries, water tanks, and any extra storage for living off-grid in there, and I should keep all my weight relatively low because it's right above the ground, and then everything else can be used for storage. I would like to not have any actual storage cabinets above. I want this all open, empty space kind of thing. But we'll see once we get the 2-foot roof raise done, how it feels in here with the floor lift. If I decide not to go that way, there's a possibility that I might just put a gray tank here and maybe a water tank, and then drop this back down and just have that as a low spot so I don't have to worry about. Like I said, I wanted to do the bus, but I could do it in a smaller space, and this is kind of what we're doing. Now, this little thing is going to have to be cut out because I have the bathtub to put in there. And I think I'm going to put it on a slide. But I don't know for sure. I got to build it first, and I got to cut that out. And I think I'll have a diverter in it built in, so if I'm in Forest Service land or land that allows gray water dumping before it goes to the tank, I can dump it and I don't have to carry around that much water weight with me, which I kind of want to keep down this time. I'd much rather have more fresh water than gray water storage. So we'll visit that later on. I really like this door though. This door is awesome because you can open it and you can leave it open. The wind can blow it whichever way, but it's not going to blow it closed. It has this wonderful little spring mechanism that keeps it open all the time. Anyhow, we are going to start with the wiring. Basically, because this cabinet's fixing to come off, and I've kind of got everything else taken out. All this wire here, this massive wire that's massive, and this is not going anything right now. Everything I want to keep intact right now is up in the ceiling. I do want to add some of this back, and some of these AC lines I'm going to reuse because they're really good AC lines. And they're huge and long, and they're threaded, and they're big, beefy wires. So, and I'll probably run them through a breaker box so I can turn them on and off from the inverter. But other than that, these are going to come out for right now. The wiring mess that's behind you guys. I don't know if you guys are watching this in regular video. It'll flash up here, I'm sure. But the wiring mess back here needs to be dealt with. I'm trying to pull this cabinet out and it's pulling this out too. So as much as I'd like to keep a lot of these wires are going to come out. The flashers are in here. I'm going to reuse the circuit breaker panel here because it has the circuit breakers, a bus bar, and a relay thing. And it's designed kind of how I want to do it. And once I get it off, I'll break down the design and we can look at it a lot closer to figure out how exactly it's designed for and what it's designed to do and what we're going to redesign it to do. And I just like the general layout of it. I was trying to build one myself so I could buy parts for it and knew exactly how it was built and go through different manufacturers for new parts for it. But that did not actually happen. I ran into a hardware issue. And apparently you can buy stuff like this, but they want $500 for like 6 of them. Well, not $500. They want $250 to $80, anywhere from $80 to $250 for something like this. As nice as this one, they want the $250 and you can get on, what is it? Some off-road audio site, which is way more than you need. I might end up building my own, but I got to get me some parts first. Mainly, I got to get these relay things, and then once I have the spacing and the everything figured out on that, I will figure out how to make a circuit board for that, provided there is a manufacturer here that will allow me to design and do small batches of it. There's Easy EDA circuit board design. And they might be here. They also might be in China, so I don't know how fast it will be to get that done. But we will revisit that later if we can, because I'd sure like to own the design or have a design in here that I can buy the parts for and know how it's built, not just using someone else's thing. Granted, there is something to be said about using someone else's thing. The main reason I'm pulling out most of this stuff, well, I would be pulling it out regular, is this is made by National Ambulance Builders, which went out of business in 2001. Another company bought it, but that company also went out of business, and that's where the trail kind of died with this design of this box. The chassis is a Ford, so I don't have to worry about that, but basically, I think the place that built this box is out of business, and most of the metal, I had no clue what it was until I found that bar over there, which told me exactly the type of metal that they're using there. It's a good possibility they use the same type of aluminum here, which is 6061, what was it? T6511, which is, okay, I'm going to use T6, I think. And that's a whole nother thing. The welding and design process will probably be its own video in itself because of what it is. But, well, I have my own design that I'm going to do, especially since if I decide to go ahead and do with the floor raise, which I'm leaning that way right now, although it'll take a lot more metal. And aluminum is not cheap. It's very expensive. To do the roof raise, to get the sheet, and build the bed platform, which most of the money's in the bed platform, which will be over the bed. That'll look like a regular Class C. And you may ask, why not just buy a regular Class C? Really, they're made out of wood, and you can't really find a diesel Class C. Very rarely, unless you want to pay a mint. So this is the closest way I can get a small Class C with a diesel engine that is built like a freaking tank. Kind of like a school bus, except for it's aluminum and not a school bus. So, and I get the 7.3, which everyone loves the 7.3, and then, you know, I heard it's a really good engine, so I went with the van, hoping that I would not be in there messing with it. Which so far has been so good. I got to do I'm probably not going to put the little ambulance thing back on with the voltage meter and all that fun jazz on it, because it's kind of a pain. I want to get the holes in the floor sealed up and get this mouse-proof too. And this didn't make it easy to do that. If I do end up reusing, I'm going to drop the wires above the floor instead of dropping them below the floor, because technically mechanically owned and operated is a lot better than if you got to keep it safety for someone else. Like if I left the stuff below the floor, it keeps it safety for the people working in here. But It's not going to be doing the same amount of driving or style that it was originally designed for, so it should last a lot longer. But anyhow, I got a paper, some tape, some pins, and a multimeter and some wire dikes and cutters. Well, wire cutters are dikes, but I got them in there. I got some tape to mark what stuff goes to and where it goes. And we're going to tackle this wiring nightmare. Actually, it could be way worse. It could not be labeled and organized. Which I'm pretty sure I'm just going to be pulling a ton of wire weight out of here. If it's anything like what's kind of hanging over my shoulder right here, which weighs a ton, yeah. But once I get this cleaned out, the main things I want to maintain that I don't want to cut the brake lights, the marker lights, and the side lights if I can avoid it. The side lights may get removed because I'm going to pull this out and break it down. And the other thing that's integral that I noticed is the warning. It has wigwags in it for the emergency lights that are tied into the main lights. So that one I'm going to have to trace down and make sure I don't mess up anything there on the truck lights. But as far as I know, I don't think there's too much integral to the engine itself. This one, I have no idea what this silver box is, but I'm sure once we get it down, we'll pull it off and see on the back. It'll tell us what it is when you look up the name. Same thing with this thing. I think this is the on-off thing that I turn on off on the side. This is the power disconnect. And see, it says ground enabled right there. Ground enabled means, right there. Ground enabled means that you switch it to ground, like put a little switch on it and it runs it to ground, and that's what pulls it and activates it. So it's a power switch. This is ground switched, I believe. A lot of this stuff is, oh look, it's even 200 amp rated. That's good. Anyhow, a lot of this stuff is coming out of here, and we'll break it down later of each individual component. And I'm going to be checking with the multimeter. Right now I'm working with hot, meaning that both batteries are connected, so this panel is technically hot. You can actually look down here and there's a little red light on saying the battery connection is on. So I don't want to get shocked or worse. So I'm going to work with it as this. If I get a spark, I'll probably go under there and disconnect the batteries. And that'll be dead in here as far as power goes. But I'm not too concerned, but I don't want to set off the airbags. And personally, I'd recommend you disconnect the power if you guys were ever going to attempt anything like this. Okay. So this unit right here, this is the flashing for the red and the blue lights that flash on the ambience, the big ones. The only reason I can tell is, for one, the wires are small, which usually signals high voltage or very low voltage because they're on for this little time. But mainly because these gray wires are what they're running to. And this is the gray wires here that I pulled out of back here that went to each one of them. And they're heavy. There's a lot of them there. So we're going to go ahead and pull this out, get the gray wires out of here. That should free up some space. This other side looks like it might be a ground or a positive. I don't know how they got switched. They got two colors, a white and red, so that could be ground switch or it could be hot switch. I don't know. We're going to get this out of here. We're going to take the ends of it and get it all the way out of here. you'll be able to read it, but it says component negative. These say component positive, so I'm guessing it's bringing the negative back here along with the positive. It's probably not using a ground in here. The ground wires that we have kind of seen floating around and drilled into the frame, I still suspect it's tied to some sort of phantom battery problem they're having in the past. So instead of running it back to the ground up here, they ran a short ground. Or maybe there's a poor ground up here, and putting a ground there fixed it. Either way, I have found that in random weird DC instances, it's usually a poor ground somewhere that's causing the problem. So that's part of the reason I want to do a bus bar with a solid ground going all the way along the cab to tie everything into, so I don't have to worry about it. I'll use probably a 4-gauge cable connecting them all together. And then I will hopefully not have a ground problem. I'm also going to use a copper bar, probably pre-drilled, tapped, and connected that way. We'll size it up for the amperage and everything, but more to come. Don't really know what these actually run to, and I might figure out where they're going before I pull them out. But I am guessing there's really not enough going back there, so... Oh. It might be going to my switch panel. These might be the ones coming from the switch panel. I don't know, find out. I don't really like the way they ran it, but they probably ran it this way to keep operators from messing up the wiring. Okay, so this power switch, the only purpose for this power switch was to keep this side and this side completely separated. These two go over to this bus bar, that one goes to this bus bar. Apparently some of these would probably be running all the time if the power switch was on. I believe this is the power switch underneath the cab that combines the two. I'm not absolutely sure on it, but that's what I believe is going on. Pretty sure this big one's the main power coming in right here. See this one here? Pretty sure that's main line, and it might be a direct draw from the whole system. We'll find out once we get in there. We should probably cover up this line because I'm pretty sure it's the main cable because it's the biggest cable. So I'm going to throw some tape over it, and when we hook up power, we'll check it, make sure it doesn't have a ton of power on it. But getting more and more off. I wonder what the pulse sound off, whatever this thing is. This will be interesting. And I'm guessing by the way that they have stuff ran, the way they got it ran, I'm guessing they had a phantom load in here or something pulling the batteries down, and they tried to fix it by taking several things out of the main loop, versus what they should have done is trace the wires down. I'm not absolutely sure that's what happened, but with all the extra additional things, that doesn't look original, because this is all original, how nice and trim, and this is definitely not original. That's not the original, neither was any of this. So the only reason I think they had a phantom load is because whenever I had this on, this will drain the batteries in a couple days. And my bus used to do the same thing, but once I isolated the system and got a monitor to monitor the voltage of it, it'll stay good for, I can leave it unplugged for a month and not worry about it, and it still starts up every time. Even now it starts up every time. And I don't even have it bypassed on, but it's good to monitor your house or your truck battery so you know what you got when you get out there in case you have a phantom load. But we'll have it fixed where we don't have any phantom loads. And if I have my way, we'll have a DC to DC converter that'll charge our lithiums as we go down the road and won't kill our electrical system. It'll give us a nice isolation. But we'll talk about that when we're going back to electrical and electrical design and all that fun stuff that's going on. We're still in Demolition, so let's get back to Demolition. Okay, so I'm going to let you guys look it up and figure out what this is. This is a really cool device. I already know what it is. I've pulled that part off of it. This is the control part of it. But it's really cool. You guys should look up Opcon systems. It's illegal to use on a private vehicle and non-emergency use, but it's an interesting device. And they had a bunch of them come out in 2000 as a kit you could make, but I think they got it under control. We're going to pull that apart later on. I have no intentions on selling it or anything like that. Yeah, we'll pull it apart and see what's on the inside. It should be interesting. More tearing apart. Now we got the doors off, the batteries unhooked. I feel a little bit safer about being in here, mainly because I'm sweating like crazy. So, yeah, we're going to get it apart and know where everything goes. Don't know what these are for. Compact. These might be tied to the switches in there. These might be the switches in the compartment, because I know there's some switch that'll turn on a relay that'll turn on a light, and it'll also light up a notice in here up there of a door being open. It's part of the reason I kind of like this, but we'll figure that out here in a bit probably. There's so much wiring in this thing. It's way more complicated than it needs to be, but it did its job, and it did its job well. Although it looks like they've added, what, 10 relays in here or more? There's some sort of random stuff, and I even seen a really janky wire connection earlier. Here's a janky wire connection. See how it's cut and spread? That is not a proper way to do a wire connection. And what I really actually like about in here is they use ring terminals, appropriate size. They did use crimp connection, but if you got a proper crimp connections do work well. Most of the time, there's not proper crimpers out there, though. So I prefer to solder them, and I'll probably solder these unless I can find my proper crimper, and I might crimp them. But they have to pass the pull test. See, that one does really good. I can even pull that one out, and it's crimped on. But if you make a crimp, and you can hook it onto something, and you can pull the wire out of that crimp, it is not a good crimp. It would not be good for anything. Ideally, once you crimp it, it's as solid as if you soldered it on as a mechanical connection. You actually should pull the wire apart before you pull the crimp out. Kind of like when you weld, the metal should break before the weld breaks. So, yeah. Yeah, I'm going to keep tearing into this, and golly, it's messy and crazy in here. But we got this thing out too, which is good. And we kind of know what we have to work with. But I almost got ready to start designing in here. I might have more underfloor storage than I know what to do with, especially by the time I get my tanks. Mainly what I'm going to put underneath the store is my gray tank, my fresh tank, my water system, my battery system. It's all going to be under the floor. Although I have some pond liner left over from another project, so I'm going to create an isolation from the electrical or the batteries and stuff. I might not put my inverter down there because I prefer to have it up high or safe from water intrusion or anything like that. I might actually end up going back in here as soon as I modify this a little bit. And yeah, this one's going to definitely be modified because I want a bathtub in here somewhere, so it might... Oh no, we'll see. We'll see where it ends up being. I mean, yeah. Somewhere. Who knows, I might make a bathtub over here, slide out, and you can look out the back door while you're taking a shower or bath, soaking bath. Which would be interesting if you're by yourself, but not so fun if you're in a group. So, I've been trying to figure out how to get a bathtub under the stars. Haven't figured that one yet. Ooh, I just had an idea. That might work. We'll research it later. Yeah, we'll research it later. Decide from there. I might just put the tub there and have it slide out. Who knows? It gives me more idea of what I have to work with once I got everything out. And now the big storage doesn't look so hidden. Before, you couldn't even tell where it was at. It was very well hidden. But they did have a lot of wasted space in here. There's probably 10 square feet that they didn't have usable in here. Alright, back to demolition. Yay! I'm gonna have to do me a pretty day because I've been wearing grungies for way too long. Maybe I'll go to the hair salon and dye my hair. I'm thinking, what do you guys think of purple, pink, lime green? Any of those cool colors? Or maybe I should just go with a golden blonde highlights.